All right, so we were doing review problems assigned for homework. Problem 39, find the arc length r equals 1 over theta from pi to 2 pi. It ends up having a very simple graph. If you graph this on your calculator, it looks like this. It's a piece of spiral that winds inward. It's just this little piece. That's all we're doing. So here's the polar arc length formula. It's r squared plus r prime squared inside of a square root. So we do what it says to do. I have to take r prime, comes out to be this, and it gets squared. So the minus sign doesn't matter because it gets squared. But I have this funny thing, 1 over theta squared plus 1 over theta to the 4th, which we rewrote with a common denominator. And then since you can take the square root of the denominator, we did. We took the square root of the denominator and pushed it out here. Let me get the camera to have the whole thing now. Hang on, come back. That's pretty good. All right, so this integral says you got to use trig substitution. So that's what takes up all this side here. All this side is doing the trig substitution. Oh, by the way, this was a Dean's question. So the trig substitution, 1 over tangent squared is cotangent squared. Square root of tangent squared plus 1 is square root of secant squared. And then don't forget the d theta becomes secant squared, d alpha. So I can't use theta for these substitutions because theta was already in use. A super weird wrinkle in a hard problem already. So I chose another Greek letter just to drive everybody crazy. I chose alpha. So all this stuff, you can pause the video and look and see all those substitutions gave this. And we picked up from here and went up here. Simplified, rewrote, and then recognized that if we rewrite this thing as this, so I use this substitution for cosecant squared alpha. Substitute in, multiply out the secant alpha, and I get something that I can do. So at this stage, inverse tangent of pi, inverse tangent of 2 pi, just use a calculator, plug them in. However, to just show you why they don't turn out so well, here's the little triangle thing. If you wanted to do it all the way out, you'd have to do this little triangle. So again, pause the video, look at how these things force this triangle. So the sine of inverse tangent of pi turns out to be pi over the square root of pi squared plus 1. I drew a face drooling because I've had it with this problem. So Ethan, if you're watching this one, you pause. Then one more last problem over here on the right. Let me make sure it's on the screen. A little bit more to the right. There it is. So this problem stands on its own. In class, we did a line in polar, and it came from this line in parametric. So suppose I gave this much stuff and asked for the derivative, which is the slope of the tangent to the curve. When the curve is a line, the answer is the slope of that line. So in this case, the way to do it is just do the parametric derivative. The derivative of 3t plus 2 is 3, derivative of t is 1, you get 3, which is what it's supposed to be. That's the right answer. But now imagine this. The polar derivative, you have to convert this to parametric and then do the formula. It takes forever, but the answer is going to come out to be 3. I'm not telling you to do that. You should do it the short way. But it's interesting to know that this massive animal turns into an even more massive animal, but it has to simplify down to 3 when you do the derivative that way. Anyway, if you're bored, give it a try, but it's not any big deal. I would never want you to actually feel like you have to do that. So that's the stuff that you missed, Ethan, on October 20th.